Your assignment for today will be in the skills practice. You're going to be working 2 through 6 and 14 through 24 all. Remember, the survey was due today, so if you didn't finish it, I'm pulling it right after school. You would want to do it when I'm done. And if you already did it by the end of the school day yesterday, I typed in your points. So you would see, oh, she got it, and it's done. So I did that for you. Your test grades are online as well, and you will get those back probably Monday or Tuesday, but the grades are in. So today we're working with arithmetic and geometric sequences. They're just plain old patterns. So arithmetic sequence, an example would be 2, 4, 6, 8, 10. 1, 3, 5, 7, 9. What am I counting by? Twos. Good. Okay. So with that pattern, could you please tell me what was the first term in my pattern? 1. Okay. So from, ooh, what happened to that? From the first term in the pattern, your a sub 1 in this explicit formula would be the 1. Now, what did I do to 1 to get 3? Add 2. That's called your common difference. So this d value would be the 2. 1, 3, 5, 7, 9. How many terms did I just name? 5. And you're going to see on this test people counting on their fingers all the time because that's how you're going to be getting your n values. So n is the number of terms. N is 5. And what was the last term in the pattern? That's your a sub n value. So we're going to be learning about all these pieces and how to use it. Most of the time, they give you 3 out of 4 pieces of information, and you find the missing link. Now, what's super important is we're going to take today's lesson, and on Monday, we're going to use this arithmetic one to find its sum. And on Tuesday, we'll take the geometric one I'm going to talk about in a sec to find the sum. And on Wednesday, we're putting all the pieces together with word problems. So you need to know everything. So if you learn the formulas day by day, then it will be much easier for you than the night before the test. Okay, next thought. For geometric, 3, 9, 27, 81. What am I doing? Good. So I'm multiplying for geometric. And what did I multiply by? 3. Good. Okay. So your R, which is called the common ratio, would be 3. What was the first term in my pattern? 3. The 3 won't always be like the same for both. R and a sub 1 can be different, but if they're the same, they're the same. Now, 3, 9, 27, 81. How many terms? That's my n. See where it is? See that exponent? And then what was my last term? 81. That's your a sub n or g sub n value. Now, whether you're helping somebody or somebody's helping you, if they've used any other resource before this one, they probably aren't using the variable g. They're probably using a's. It is fine. It's interchangeable. The old resources would say a sub n equals. This one uses g for geometric, a for arithmetic. But it doesn't matter. They're just unknowns. Okay? So the explicit formula is a great formula because it gives you that missing value you're looking for. The recursive formula only has one purpose. It gives you the next term in the pattern. That is it. So its general format of a recursive formula over here is a sub n. So look at the subscript with me real quick. Do you see a subscript of an n? Do you see a subscript of an n minus 1? Would you agree that n minus 1 must be 1 before the n? If n is 7, then n minus 1 must be 6. Good. So that's saying take the term before, add something to it to get the next term. And you're going, yeah, I know that. That's what the formula says. Okay? So there's actually something that tells you what to do, and it's going to give you a starting term. The same thing works with geometric. It says take the term before it, multiply it by something to get the next term. So that's also on that formula sheet I gave you on the back of your study guide. So everything was there, so there's no surprises. Questions on thoughts? Yes? We're not doing infinite, we're only doing finite. So, yeah, so what I need to know next is what is the difference between the word infinite and finite, just in general? You know this. Okay, good. One has a limit. It stops. Which one does? Good. Finite ends. It's finished. Think about even like in movies when it's finished, an old movie. I'm dating myself there. Infinite goes on and on and on forever, the dot, 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 dot. We don't do infinite series anymore because it's not part of the curriculum. They're kind of easy and fun, but it's not part of the curriculum. We're going to do a finite series that has an end. There's a certain amount of terms. However, on my test, if you don't know the formulas, you don't want to be sitting there for 15 minutes adding up the first 29 terms because, which you first have to list out because you forgot the formula. That's why you need to learn them. And every year there's somebody that doesn't do the formula, and I look at their work, and there's just columns of numbers that they listed because they forgot what to do. That takes way too long. Okay. Here is just in your textbook talking about arithmetic and geometric sequences. Now, I know that if it's arithmetic, it's usually pretty obvious how to come up with the value. And your arithmetic difference, that common difference, can be a positive, it can be a negative, it can be a whole number, it can be a fraction, it can be a decimal. When you deal with your R for your geometric, you're multiplying. You can multiply by a fraction. So think about this. If you multiply by 1/3, it's the same thing as dividing by 3. But so with these geometric, you don't say I divided by 3, you convert it over. I multiplied by 1/3. R is what you multiply by. You can multiply by a positive or a negative. Now, what if I give you that pattern again, 3, 9, 27, 81? I need to figure out a rule so that if it's a harder pattern, I would know what the next term is, like what I have to do. So you know that you're multiplying by 3. We already said that. But what if you didn't know that? With that pattern, just with those 4 numbers, let's come up with a rule so that, given a pattern, I could figure out what R is without having to guess.
Take the second term and divide by the first.
Bingo, that's it. That's the rule. You take the second number, 9, you put it over the first one, 3, you get your answer. So maybe you don't like those numbers. Maybe they're like too big of numbers. You could put the third over the second, or the fourth over the third. So the next one over the one before it gives you your R. So you never have to guess. Okay? So some quick patterns for you so you can see the sequences. Look up there. I just wanted you to see the obvious. Look at the arithmetic. Look at the geometric. Notice with arithmetic, I call D equals for your common difference. For geometric, I write R equals. I did a fraction as well, so you could see that, yes, we could be multiplying by a fraction. Check this one out on the last one. So using that rule, second one over the first. If I put 36 over 54, we want to reduce it, of course. What's a common multiple of 36 and 54? 6 works. I can go bigger. 18, bingo. So 9 works in one of the classes. Somebody else yelled out 2. So then we put together the 9 and the 2, and that gives you the 18. So 18 goes into 36 twice. 18 goes into 54 3 times. That's the R that's your 2/3. Okay? So yes, you have to know how to multiply and divide. This was the frame I had up for you guys earlier. It is the same rules. It's just giving you the verbiage of where A sub 1 is the first term, so you know what it represents. D is the common difference, so you know what D represents. N is the nth term in the sequence, so that's the number of terms. A sub n is the value of the term. So 3, 9, 27, 81, n is 4. There's 4 terms. A sub n is 81. It is the last value. If I went blank, 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 in the last blank, I would put the 81. Okay? Again, if you're tutoring, you might have to distinguish between the two with whoever you're helping. With the geometric sequence, your G sub 1, again, is your first term. That little subscript 1 means the first one. The R is the common ratio, and again is how many terms are there, and your G sub n is that last term in the pattern or the one you're trying to get to. And we'll talk more on the recursive when I get to the examples. So this is right out of the textbook. page 470. So whether you write it down, you cut it out, you took a picture of it, whatever it is, before I change frames, does anybody need a picture, even though it's in your book? No. Good. Okay. Okay, so here is a story problem. The employees at Franco's Pizza Shack turn the pizza oven down to 200 degrees overnight. When the workers open the shop in the morning, they turn the ovens up to 550 degrees. The temperature of each oven increases by 40% every 30 minutes. Will the oven reach the required 550 degrees in an hour and a half? Okay, so what is your beginning temperature? 200. Okay, so we're going to start with 200. I'm going to build a pattern here. Now, that is 100% of the value to start. It's increasing by 40%. So do you think I should multiply by 0.4 for 40% or something else? 1.4, perfect, because 100% plus 40% is 140%, which is your 1.4. So you need a calculator on this. So I need to know if we have the value 200 and we multiply it by 1.4. What do you get? Yell it out. 280. Okay. So 200 was at 0 minutes. 280 is 30 minutes in. Oh, the oven better hurry up. Now multiply by 1.4 again. Yell it out. Good, 392. So now we're an hour in and the oven still hasn't even hit 400 yet. This guy's going to have to get in really early, isn't he? Okay, now you want to multiply by 1.4 again. What do you get? Okay. Would you agree an hour and a half has lapsed? Shake your head. Okay. So now if an hour and a half has lapsed, that's what the question is asking about. It's saying, will the oven reach the required 550 degrees in an hour and a half? Is it there? No, I don't want an ish value. It is not there. No, it is not. When we just built this pattern, we were actually using a recursive formula because we took a term, the first term, we multiplied it by r to get the next term. You took the 280, you multiplied it by r to get the next term. That is what the recursive formula does. That's its only purpose. And we'll actually list out the true formula in a sec. Now, up here, what I typed in for you was putting it in formula form if you knew a lot of information. My a sub 1 was my 200. My r was the 1.4. What is 4? Where'd that come from? But how did I know I was looking for the fourth term in the sequence? I had to do something. Okay, so each time, so 0 minutes, half an hour, an hour and a half. Okay, so you could do that, cut that on your fingers, even if you didn't know those values. Couldn't you do that? That is the 4. That's the n. So in your calculator, you would want to do 1.4. What does 4 take away 1? 3. I would think you don't need a calculator for that. So you're going to cube it, and then you're going to multiply by 200, and you would get your solution. That would be using a formula. This is the explicit formula. It gets you right there. It is plugging in a couple numbers, calculator, and you're done. You want a scientific calculator, not my little 4-function ones, because I don't think the 4-function ones have an exponential key. So don't forget, way back in August, I told you to buy those calculators if you didn't have one, and it's going to be December tomorrow. So you had enough time to get a $10 scientific calculator, okay, or find one or borrow one. Okay, so this is the beginning of the homework. I usually skip over it, and the year that I did, it's so easy that people didn't know what to do. Some of them missed it because they were like, that's all I had to do. So do you see a pattern? 1, 3, 9. Is it arithmetic or geometric? How come? You're multiplying. Good. So you're even explaining to me what you're doing. What is the R? Done. Okay. Look at the next pattern, number 2. It's arithmetic Because you're adding 2. Very good. Ooh, look at this one. 3, 5, 9, 15. Boy, I'm hearing grumbling. Different. So, but in order to be, so you're bringing up a good point. In order to be arithmetic, your common difference has to be exactly the same every time. In order to be geometric, your R has to be exactly the same every time. Is there a value that you can add or multiply by every time to get the next term? No. So it's neither. It's going to be a neither. Okay? So be careful with that. Don't let it trick you. It's not meant to trick you. This is definitely a pattern. It's just not arithmetic or geometric. Okay, next thought, more problems. This is where we're working with the recursive formula. I want you to see with the recursive formula the only parts that I really need you to write in, because you don't need to write everything. You're going to derive the formula from the pattern. The formula will start off with an a sub n equals a sub n minus 1, and then you're going to have whatever your difference or r is. So would you agree the difference here is negative 2? So that's why I put plus negative 2. You truly don't have to put the plus. You could have just put minus 2. What was the starting value? 5. So if I said build a recursive formula for this pattern, that's what you would write. Part B. What is the next number in the pattern? Positive or negative? What comes after this? I don't need to see the work for that. I know you can do that in your head. Okay? Next one, look at my pattern. Negative 2, negative 4, negative 8, negative 16. Arithmetic or geometric? Awesome. What is your R? 2, plus it's up there yelling at you, right? Okay, so we know R is 2. We want to build an equation. So I would say a sub n equals a sub n minus 1, or you can use your g's, whichever you prefer, times how many? 2. Yeah, that's what you're multiplying by, where the first term is, what is the first term? Yeah, that's it. And some sites, some tests, things like that, instead of an a sub 1, they might write it as an a sub n minus 1 there. It's interchangeable in that kind of formula. I would obviously take either. I just wanted you to see 17 to see that sometimes you could end up with decimals. It's still the same idea. This one right here, you're adding 2.3. You still work it out the same way. It's just a decimal. Question on this type before I get to the good one, the explicit. Okay. So the explicit is my favorite because it serves more purpose. So on the example up there, number 20, 3, 6, 12, 24, what are you doing? Yell it out, quick. Multiplying by 2. So if you're multiplying by 2, it must be geometric. So the first thing it says is say what it is. It's geometric. When you go to write your formula, so on the test, your part A would be derive the formula for this problem. Don't give me this generic one. Give me the one that goes with the problem. So what goes with this problem would be g sub n equals, what's your first term? Times, what's your r? To the n minus 1 power right there. That would answer the question. Okay? Now, it wants me to find the 35th term. So yes, I could sit there on my calculator and go 3 times, 2 times, 2 times, 2 times, keep getting the next until I've got 35 deep. Or I could plug 35 in for n. 35 minus 1 is? Take 2 to the 34th, multiply it by 3, and you're going to get a big number. 9th graders, do you know scientific notation? Have you learned that yet? Earlier, 8th graders? Okay, so this is scientific notation because it's such a long number. So it was 5, 1, 5, and it kept going and going like the whole screen. So if it's a huge number, scientific notation is okay. Okay? So, let me finish up, guys. I only have 5 minutes. So next one we have 0.21, 1.8, 2.6. What is happening here? Adding how much? Okay, 0.8. So do you know what your first term is? 0.2. Good. So our format would be a sub n equals 0.2, which is my first value, plus, what did we say d was? 0.8 times n minus 1. That's it. Now, if I want to figure out the value of the 35th term, you're going to put 35 in for n. 35 take away 1 is 34. 34 times 0.8, then add 0.2, and it will give you your solution. Question. Sequences and series tests can be really easy if you just do it day by day, like learn, absorb everything that we do each day, or it could be hard if you wait until the last minute to learn all the formulas and trying to put everything together, because it builds each section. Okay? So please don't procrastinate. Here is your assignment. Get that survey in to me if you haven't done it yet, because I'm pulling the report at the end of the school day. Good job, guys.